Hi, everyone, and welcome to our September Fireside Chat. My name is Alex Dolk, and I'm the Program Manager for Northwest Natural Resource Group, or NNRG, if this is your first time joining. NNRG is a nonprofit that helps people put ecological forestry practice into their lands, and we work with landowners across Washington and Oregon to steward, certify, and harvest and manage their forests. And several of the folks here are landowners and NNRG members. We have been doing these Fireside Chats for nearly 2 years now, and if you've never been to one before, Fireside Chats are monthly community events where forest owners and forestry practitioners are invited to come together to learn about and discuss interesting and emerging topics in forest management and to connect with other forest owners. And we host these on the third Wednesday of every month at 7:30, and we've covered a huge variety of topics so far, everything from Washington forest taxes to filling out forest practices applications to wildlife habitat, piles and structures and invasive species removal, etc. And I'm excited to be hosting tonight, but I am subbing in for our regular host, our Director of Forestry, Kirk Hansen, who isn't available tonight. But I'm joined by Matt Distler, who is the Conservation Program Manager at Oxbow Farm Conservation Center. And we're going to be discussing the ecological context for assisted migration in the Pacific Northwest and the ethics and risk management strategies that folks utilizing assisted migration are considering and talking about. And assisted migration, in case you're new to this topic, is the human-assisted movement of species in response to climate change, but it encompasses a bunch of different things, and I think we'll get into that a little bit soon. So as I said, Matt is the Conservation Program Manager at Oxbow, and Oxbow Farm Conservation Center is a nonprofit that's focused on research, practice, and education around issues of sustainable land use and conservation. And it's a really cool place up in kind of between Duval and locations, if you ever have a chance to visit. I want to say I recommend it, but I actually haven't been, and I will get my first chance to go next month. So I'm sure it's wonderful. So I think I can recommend it without having been there, but Matt can tell you more about it too. Matt's research and restoration work over the past 20 years or so have encompassed innovation biology, Holocene, paleoecology, wetland science, land management, and wetland forest and riparian restoration. And currently his work focuses on wetland and riparian restoration and wildlife monitoring on working lands in Western Washington. And if you're fascinated by this topic, assisted migration and climate adaptation, and feel like you just got a taste tonight and you want to learn more, Matt and I are both going to be in attendance and helping to lead a tour of assisted migration and climate adaptation projects on Friday, October 6th, from 9 a.m. to 1:30 p.m. And that's taking place at Oxbow Farm Conservation Center in Duval. And after our tour at Oxbow, we're going to another site called Stossel Creek, which is closer to Carnation. And that's a reforestation project along a salmon-bearing creek that NNRG has been working on along with Seattle Public Utilities and Mountainstown Greenway Trust. So I'm going to pop the link to that tour in the chat. You can find it. And if you are interested in that, close enough to attend, I encourage you to sign up because spots are filling pretty fast. With that, I'll hand it over to Matt. Matt's going to present for a little while, and then we're going to open up the discussion, open up the floor to discussion and questions. Feel free to put questions, if you have questions throughout Matt's presentation, throw them into the chat, and we will go through them at the end of the presentation. And, you're welcome to ask more questions then. So, Matt, why don't I turn it over to you?
Great. Thanks so much.
Want to share the screen?
Thanks for inviting me here. And yeah, I'm excited to talk to everyone here. I guess I'll jump right into my presentation if I can figure out successfully how to share my screen. All right, are you able to?
That looks good. We can see your slide.
Nice. All right. So, as Alex said, I'm a conservation professional at Oxbow Farm Conservation Center, a nonprofit, and we among other things, work to restore some of the streamside forests to help support biodiversity and ecosystem functions in working lands in Western Washington. And because of that, the fact that we're sort of starting new forests and hoping to start forests that are well adapted to future conditions, we're very interested in this question of how will climate change be affecting our plantings and our projects and our ecosystems around Western Washington. I actually got interested in this question of assisted migration years before when I was working at urban forestry and urban forest restoration. It's just at the city of Mercer Island. And we sort of began to question, we got a sense of the climate projections and the fact that the seed sources we were using might not be well adapted in the future, and started that conversation there. But today I want to, I've got up in front of you a picture of the assisted migration trial project that you could come and see if you came on that tour that Alex was just describing. But I'm not going to talk about that today so much. Happy to take questions about it and talk a little bit more about the logistics of that particular and the purpose of that particular effort. But I'm going to talk a little bit more about the philosophical, ethical risk assessment underpinnings of the whole question of assisted migration. And I should caveat that by saying I'm not an ethicist, I'm not a philosopher or a, conservation legal scholar. I'm a restorationist, and I bring that viewpoint, and I'll be speaking from the point of view of someone just trying to figure this out over the years and how that affects how we can do our work effectively in restoring ecosystems. So I'm also not going to go in depth into the science of climate change. There's not time for that, and a lot of folks have covered that better than I could. But I'll start out by saying, if you read the news or read the scientific literature or even look around you, we see the impacts of climate on, our Western ecosystems all the time. Massive blowups of mountain pine beetle in Canada and the Western US. In recent years, Doug fir singed by this heat dome a couple of years ago, seen up and down the I-5 corridor if you drove there, and sort of mysterious dieback and forest health issues among some of our foundation Western forest species like Western red cedar and big leaf maple that are really concerning and really emphasize the need to take some adaptation actions to help keep our forest health and help our environment and our cultures to adapt to climate change. And one of these tools that is being considered is assisted migration, among a wide portfolio, I should add, of other tools, some of which are much better tested and are being used to help us adapt to climate change and to help us mitigate climate change. All that continues to be super important, but assisted migration is one approach that holds some promise for helping our forests and our rare species adapt to climate change, but it also is somewhat controversial. And Alex gave a definition. I'll just say again that it can be defined, among other ways, as the intentional movement of plant materials, in this case, or organisms, in response to climate change. It's also sometimes called managed relocation, assisted colonization, facilitated translocation, lots of synonyms. And before I sort of jump into kind of the nuances of how people are looking at it right now, I want to just cast it a little bit in context, like where did this idea come from in the first place? And maybe go back as far as to say that, a few hundred years ago, and for some hundreds of years, probably our Western view of natural systems was that they were fairly stable, that they had an equilibrium, that they had checks and balances, and there was a harmony of nature that you could expect in systems, and they probably would not change much over the long term. And this became challenged more and more, especially in the 19th century, with the work by geologists, James Hutton, Charles Lyell, Louis Agassiz, who began to show us through geological evidence that there have been these massive upheavals in the Earth's crust, in these glacial episodes that we began to see evidence for. And then into the 20th century, as we began to pin down these methods of palynology, pollen analysis, radiocarbon dating, other paleoclimatological and ecological tools, we began to get a much more detailed perspective, understanding of the dramatic changes that actually have been happening in our forest and other ecosystems over time, over thousands of years. And here you can see on the right-hand side of my slide some sort of diagrams put together from this pollen work by Margaret Davis, one of the pioneers of pollen analysis in the mid-20th century, who, through putting together pollen diagrams from many wetlands and lakes in eastern North America over time, put together a picture of the movement of our forest species, which once might have been considered to be these sort of ancient and relatively static groupings of species, that these actually moved hundreds of kilometers over the Holocene, the period after the last ice age, northwards in response to warming climates over that time period. And you can see not only that is that the case, but if you follow these sort of isopleths, these lines across these maps for these different species, you'll see that on the bottom half, like the oaks and elms moved individualistically up from sort of the southwest part of the Appalachians, whereas like hemlock and white pine had glacial refugia where they had, hidden out during the ice ages in the Carolinas, and that we began to understand that despite feeling like forests were immutable, mix of species that may have always existed, the species had actually moved individualistically over time. And of course, when I say that they moved, these are not J.R.R. Tolkien's Ents that were pulling up stakes and wandering across the landscape, but unlike animal species that can move, these are migrating by the dispersal of seeds and pollen, and colonizing new ground and maybe losing ground as the climate became unfavorable at the southern edge of their ranges, and moving that way generation after generation. So this all began to build even before we began to understand the impact of anthropogenic climate change, build a new vision of natural systems in which there were dramatic changes in ecological systems over time, where climate was ever changing, and began to shift us in our understanding of the goals of conservation as well, although very slowly, to an understanding that we may not be able to always restore and look back to static baseline conditions in our ecosystems, but in fact, we're managing a moving target. And so this is, I think, a background to some of our discomfort about the idea of assisted migration, that we were already experiencing sort of cultural discomfort in the way the things we're learning about nature. So as we began to understand that there was also this added disruption of anthropogenic, of human-caused climate change coming at us, some of the science around the paleoecology of our tree populations and plant populations became more and more important for that reason as well. We looked at those paleo historical records and tried to figure out, well, how fast were those trees moving? Actually, this might actually be important now. And can they move quickly enough to keep up with the climate change we're now projecting through our global circulation models and climate projections? And most of the estimates from our paleoecological research showed that trees seem to be able to move. Well, these were eastern forest trees, a particular set of species in a particular part of the world, but could move maybe 20 to 40 kilometers per century over that time after the end of the ice age. And so I've mapped out a century's worth of change on the right-hand side here on the map of Washington. You can see a little black arrow from like Seattle-ish to Everett-ish. Now, from current climate projections, it's thought that in order to keep up with the projected climate changes, plants will likely need to move something like 300 to 400 kilometers per century to avoid being maladapted to future climates. And I put that arrow on here as well in red. So you can probably see the problem there. From our current understanding of those capacities of movement, it looks like plants, and this has also been shown to be the case for a number of animal species and other migration needs for our biota, are going to have a very hard time keeping up with at least what's projected for climate change in the coming century. So that is one of the reasons why we're considering this tactic. Along the way, we're learning something from forest ecologists and forest geneticists about the ways that plant populations likely did their movements, what the actual details of those migrations might have looked like. And this is a little bit of a complicated graphic on the bottom, but it sort of shows these little bars of gradient being the climate moving to the right or moving northward, perhaps it is. The bars and those red letters, and different populations of a particular species that can be locally adapted to their environment within the range of a species based on soils and particular climates in the parts of the range that, say, if you imagine Douglas fir has a lot of areas across the western US where it grows, and in those places stands of it are locally adapted to the climates where they're existing. But if the climates are moving, the thought is that the way populations probably adapted and shifted was, yes, at the very northern edge, they were spreading seed into new area, and maybe at the southern edge, they were dying off. But also in between, genetic material in the form of pollen, and maybe also seeds, were moving from population to population, such that perhaps pollen from our southern population was helping to hybridize and add genetic material that was adapted to warmer temperatures into more northern populations. And over time, those sort of warm adapted hybrid individuals would be more likely to survive well, and the genes that are well adapted to warmth would kind of move their way up north in the population, sort of in the same way the species itself would move north through setting seed. And so that sort of idea of locally adapted populations and the genetics of those populations being important also sort of took root in the literature and in our understanding of how plants might react to climate change. So that's a lot right there. It's probably things to talk about at the end if there are questions, but that's sort of some of the setting of our understanding of both how plants might adapt to climate change, and in the past it might have adapted and might adapt to the future. So another part of this is that this is already happening according to our evidence, our modeling, as well as our field evidence. From our best evidence, there's probably been over a degree of warming even in our moderate Pacific Northwest since the 1800s. And a number of studies have already shown that populations of, locally adapted populations, I was talking about, of certain tree species, are already showing that maladaptation to the current climates, because the climate has sort of apparently run away from them already to some extent. And I'm not going to go into much detail, but you can see a graphic on the right from Laura Gray and Andreas Hamann up in BC, where they studied a number of populations of aspen across Alberta, and showed in a number of cases that those populations, populations from further to the south were already better adapted to the environments of more northerly populations. And they looked at a number of like common garden field trials there, as well as modeling climate change. So we have a situation where we may already be seeing that maladaptation of locally adapted populations within trees. So we sort of built a little bit of a case for this, at least more, I have to admit, in this sort of forestry context, where we're looking at the genetics of common forest trees. We'll come to talk a little bit more about the maybe more controversial part of assisted migration in a moment. But in general, you know, we have a process of helping perhaps trees and other plants and maybe animals as well to move northward in a way that they would under natural conditions of climate change, like after the retreat of the last glacial ice. But because trees are already maladapted to current climates and probably, as we foresee, unable to move fast enough, it might make some sense to help them move to these new locations, or certainly to help populations, you know, sort of the genetic pre-adapted, you know, genetic capacities within plants to move northward, especially given that there are also anthropogenic barriers, agricultural areas, cities, roads that didn't exist in earlier cycles of, you know, migration along forests. So this is a great graphic that was produced by folks from the Forest Service to kind of describe as the discussion of this idea started to move forward at sort of the turn of the 21st century, some ideas describing kinds of assisted migration. We're going to start looking at just the right-hand panel, because when the discussion first started about assisted migration, it was actually mostly what's sometimes called, in the context of conservation assisted migration, or assisted species migration, or also sometimes called rescue, species rescue migration, which is sort of what it sounds like. What's sort of the graphic there on the right-hand side shows this tiny little green dot, which is the endemic range of Torreya taxifolia, which has sort of become a poster child for this form of migration, because it is a narrow Florida endemic tree that many consider to be sort of trapped because of barriers of dispersal from moving northward after the ice ages. And a group of concerned citizens, the Torreya Guardians, headed up by Connie Barlow, decided to take matters in their own hand and both sort of publish some discussion of the possible importance of moving rare and failing species that are impacted by climate change northward into areas where they might succeed and thrive in climates that actually suited them better. And then they actually went ahead and did it. They moved a bunch of individuals of this species and planted them, or propagules planted them in a bunch of different places pretty far north of its current range to see whether they could save this highly threatened species. And this kicked off, this was like the opening salvo of the great assisted migration debate. And a number of other conservation biologists concerned about failing, you know, species spoke up and said, this sort of makes sense for some of the reasons I outlined above. And then some, figuratively speaking, some of the invasion biology experts in the room, Daniel Simberloff and Anthony Ricciardi, sort of raised their hand and said, oh, good idea. What could go wrong? So I just showed you a southeastern forest entirely consumed by kudzu, that was introduced for soil conservation from Japan and China. The cane toad, which was introduced into Australia and has taken over half of northeastern Australia. And then, of course, on this slide, Himalayan blackberry, which you know about that, I'm sure. Emerald ash borer, an introduced pest that's wiping out ash trees across the continent now, and Japanese knotweed, right? Invasions of plants and animals that we have moved around the globe have cost so much treasure and ecological harm, right? And biologists spoke up very quickly and said, this is a terrible idea. We should not be moving animals and plants around willy-nilly. And that was the beginning of a conversation that quickly became much more nuanced in a good way. And this is, I come back to this slide because in the 2010s, added into this conversation were the input of a number of forest geneticists and ecologists who spoke up, including Mary Williams and Caston Dumrose, who created this graphic and said, well, on top of all the complexities of what you're discussing with species rescue migration, there are these other kinds of plant material movements that we've been considering seriously that could be put under this rubric of assisted migration, but are really kind of different in nature, but also different kind of in their risk profiles. And we should discuss this. And we should begin to try and tease apart what the risks and benefits of these different kinds of assisted migration are. So on the left-hand side, we have something that has been discussed in great detail now in the forestry literature and conversation, public conversation, called assisted population migration often. Sometimes it's called assisted gene flow. And it's the idea that, as I was sort of alluding to, talking about the local adaptation of populations, that you can move propagules from locally adapted populations of a species within the range of that species, not necessarily going outside of the range of that species, in order to better adapt, provide better adapted individuals to be added into these local populations, and perhaps to influence the genetics of those local populations to be more, to be well adapted to coming climates. And then there's sort of a middle case that's in the middle of the graphic that could be termed assisted range expansion, which is kind of like assisted population migration, but what you would do as you got to the northern edge of a species range, where it might be able to and might naturally begin to colonize new areas where perhaps other species are failing due to climate change, but may not be doing it rapidly enough to keep up with climate change. So moving seed into those areas could be considered a form of assisted migration also. And from there, I think very usefully, the literature has begun to try and sort out, like, what are the kinds of risks that exist for assisted migration, and how are they distributed across these different actions that might be considered assisted migration, that have different risk profiles, and how could we then mitigate for those, and in what cases can we mitigate those risks, and in what cases, and how do we decide when it's not worth it? So I'm going to run through some of these kind of quickly to give you a sense of the kinds of risks we're looking at, and then some tools that people are considering to help make these decisions. So we mentioned, the fact that invasion biologists were up in arms saying, this is a huge risk of invasion. So that's definitely something we need to consider whenever we do assisted migration actions or consider them. And aside from the sort of most obvious case where you're introducing a plant or animal into a new environment where it will do too well and compete with native species, you also have a situation where you might introduce a species that itself isn't a problem, but is closely related to another species as a congener in the receiving ecosystem, and it might hybridize with those, and the hybrids can be invasive. This is something that actually I did dissertation work on hybrid cattail, which is sort of that exact situation on the East Coast. So this happens. And also a thing that maybe I'm worried about more than anything else at this point is that you may inadvertently introduce organisms that are not even the target organism, but pests and pathogens that can move when you move plant materials. So for instance, I'm very concerned, and many other folks are as well, about the movements of Phytophthora organisms, these oomycetes that are plant pathogens and include, the species that causes sudden oak death and a number of other plant diseases that are easy to move with plant materials. A second kind of problem is actually just the alteration of culturally important ecosystems, that you can impact culturally important ecosystems and move culturally important species. And I think this has the potential to impact lots of people, but certainly is maybe of particular concern where indigenous peoples have very close relationships with and reliance on first foods and other native species. Finally, there is the potential that has been raised by a number of people that you could actually degrade protections for the environment just by sort of opening this Pandora's box. If you say, we have this tool that might help species adapt, but it requires us to alter these ecosystems in this way, there's a chance that there's sort of a moral hazard there that once you open that can of worms, people might decide, well, okay, maybe it's not so important that we worry about climate, mitigating global climate change, or that we take maybe more proven methods, or we keep up more proven methods to conserve habitats and species in place, and that we reduce our emphasis on those to their detriment. And finally, just as a tool, it might take away resources and attention from more effective conservation tools. Those are all possible areas of concern. And even in the case of assisted population migration, there are chances that you could cause outbreeding depression, which is to say adding more poorly adapted genes into a locally adapted population where there isn't historically enough gene flow, and these basically aren't able to adapt to the new genetics coming in. There's a chance of just failure of some of these assisted gene flow efforts due to a poor match in climate. The modeling wasn't correct, or a poor understanding of the biology of the species. And possible poor performance due to non-climate related adaptations of local populations, like adaptations to mycorrhizal communities, to soils, to photoperiod, things like that. There are a lot of risks to consider, but it's also important to consider that no action is also carries a risk. So as we sort of try to begin weighing the costs against the benefits, we have to realize it's not a question of how much risk do we dare take in moving something. It's how do we weigh that against the risk of no movement. There are some other ways we can begin to specifically assess the risks of each, the levels of each of these risks I've talked about. Just quickly, I'll say that for invasion risks, for example, while invasives are a huge problem, it's actually a very small proportion, maybe 14%, according to a recent meta-analysis of invasions in North America that are intracontinental. So almost all the invaders are actually from another continent, and that amount of ecological change seems to be something that sets us up for that kind of mismatch. So a very much smaller proportion of invasives come from the kind of movements we'd probably be considering in assisted migration. And we can also, to some extent, especially in plants, use species traits to assess the risk of invasiveness. So things like plants that grow very quickly and put very little effort into protective chemistry and are related to other plants that have been invasive. There are a number of, there's sort of a checklist of traits that are associated with invasion and can be used to assess that risk. And certainly there are a number of best practices that can also be instituted and used to reduce pathogen transmission. So it's not like there are no ways to assess and reduce these risks. Similarly, though more complexly with the potential for cultural damage, I think these are areas where science is very good at dealing with technical problems, given enough time and people thinking about it, but cultural problems and societal problems always are more difficult. That being said, I do think opening up organized, transparent public conversations about our conservation values as a society and about the decisions we might make is one really important step I think we need to take, especially for certain high risk proposed actions in the area of assisted migration. We also can learn from our elders socially, so to speak. Traditional ecological knowledge is becoming a more and more important kind of knowledge, where the things that indigenous societies have learned about their native ecosystems can really be important sort of bedrocks for our understanding of how ecosystems will change. And I think that's a tool we will rely on more and more. And it is also possible that assisted migration, though it could be a moral hazard, could also be an outreach mechanism to society to engage people more in this conversation about how we manage our resources. Running a little long here, I think, but I'm getting close. So in recent years, there have been helpfully a number of sort of risk reduction tools and frameworks that are being developed that sort of organize these ideas into conceptual tools that people can use when they begin to consider these kinds of movements. The National Park Service has created a really promising one, I think, that you can kind of see a little section from it. It's sort of set up as a spreadsheet on the right, where it goes through sort of line by line the various previously identified kinds of risks and benefits, both to the target organism that you might be trying to move, a target population, but also to the receiving ecosystem, and goes through in a systematic way and asks, practitioners to bring together experts and to consider the amount and the agreement of evidence for each of these questions about how we might be putting at risk various ecosystem services or various species from a genetic and ecological point of view. There's also a sort of similar framework put together by Thomas et al. Just a little flow chart that I've shown on the bottom. That's part of a much larger system and this one focuses again on the costs and benefits trade-offs to the target organism only in this case, but helps you walk through logically what risks you might be incurring. And then last, I would say that actually our own Deer Forest Adaptation Network, with which NNRG is an important leader of, is also working on a conceptual framework that will hopefully help those of us thinking about these ideas in this region to work through sort of a flow chart of risk assessment. And I think it actually incorporates the National Park Service risk assessment in it, but that's still in process. Brenda Clifton is working hard on it right now, probably. So I've talked a lot, and I'm coming almost to the end here, about sort of the risk assessment side, which I think is a really important part of sort of how you ethically consider assisted migration. Like what are the risks? What are the benefits? But there's sort of another element to it, which I won't take as long to go through, but in fact is probably the more complex part. But it's one that which I don't have too many answers for yet. I've read a lot of intriguing things about it, but it's a lot of these sort of societal questions beyond traditional risk assessment, like these questions of who benefits from assisted migration, from any given assisted migration action. I think we're realizing that, this is a question that we need to ask at the beginning and the planning and the proposing stage of any of these kind of conservation actions that might have substantial, impacts on our ecosystems, not at the sort of tactical stage where we're like, well, we're thinking of this A, B, or C way of doing this. Let's get some public comment. And attached to that, this question of like, well, who makes decisions or who has input on these questions? And I think, again, scientific methods are great in protecting kind of objective approaches to answering a question about nature, but they're not always so great at removing the bias in what questions we're asking. And I think that's an important thing to recognize, that sometimes we get to the wrong answer because we're asking the wrong question. And part of asking the wrong question is that you might not have the right people in the room to think of the right question. So I think this question of who are the stakeholders that might be impacted by these conservation decisions we're trying to make. And often, importantly, who are the ones who are not usually at the table, but are going to be influenced. So understanding how we both reach out to and include people who might be impacted by these, but also how we weigh, the opinions of different groups who have opinions about these actions is very sticky. And along with that question, also sort of what level or what kinds of risks warrant public involvement of what kind. In some cases, we could have sort of operational work that needs to be done by agencies and cities and private companies or nonprofits. And in other cases, they turn out to be decisions that are irreversible and really needed more public discussion. And beyond that, there are maybe even larger questions of how do we consider intergenerational equity? We're doing a lot of this in some, in a way for our children and children's children, and they are not yet at the table. And questions of interspecies equity. Do the species themselves have rights? Do they have interests in this, and who speaks for them? I'm just going to close with a few just words about where things are as far as I understand them in actuality and what people are doing. I feel like I have a fair amount of work to do to keep up with all that's going on. So there may be actions that people are taking I'm not aware of, but certainly in BC and Canada, there's a lot of assisted forestry migration work already being done. They already years ago modified their standards for seed transfer to allow upslope planting to keep up with climate change. They allow western larch to be planted north of its current range because of so much damage from western pine beetle and fire. They're just trying to restore landscapes in ways that are climate stable, and now are basing their seed selections on this climate-based seed transfer system that uses climate projections to tell foresters where is going to be the right place to plant your seed, such that it will be adapted in the years to come, and relaxing in other transfer guidelines that way. And lastly, I'll just say that where the sort of gestalt of especially sort of the forest ecologists recommendations for climate change based on what we know so far, or sorry, for assisted migration action, they're saying we've got projections going out many 100 years, but we should aim for at most 20 years in the future for what seed we're looking to use, and maybe 2 or 3 degrees of latitude of movement at most, because beyond that many years, the projections, the models stop agreeing so well. It's not as rock solid, and you could make the wrong decision. And seedling and saplings really are the most vulnerable stages, and so if you can get them through that stage, the adult trees are more adaptable, and larger shifts that you might make ignoring this would have more risk. Include a portfolio of genotypes if you're doing forestry work using this. Hedge your bets. Don't just pick one projection and go with it. And I would say, and a number of other folks would say, only engage in assisted migration if you're able to monitor outcomes, and even maybe if you're able to share those outcomes more and more with the community of folks studying this. And if you're interested in this and unsure, talk to us at the Forest Adaptation Network, because we are currently working on putting together ways to share information on assisted migration plantings and learn from each other. All right, I did go over time, I apologize, but there is still some time for discussion. I want to thank the Cooperative Watershed Management grant round for funding our work, and the Snoqualmie Indian Tribe as well, and also thank Forest Adaptation Network, NNRG, and our partners, Coos Watershed Association. And with that, we'll stop sharing and take questions.
Thank you so much, Matt. That is all really interesting. And we do have some questions in the chat. So let's get some of those first, and then we'll open it up to everyone. Tyler asked, are mosses and fungi, lichen algae, are they also being considered in human-assisted migration, since they're also critical species for the health and survival of plants and animals? And I would add to that, understory plants. I mean, most of the trials I hear about are trees.
Mhm.
Do you know of any trials that are doing that with more
Yeah,
types?
so I am not aware of trials and research focusing on like mosses and algae and some of the quote lower organisms that are so important. Um, but I do know there's a lot of the Forest Service has done some great work like on grasses and Great Basin restoration work. There's definitely some work being done on shrub species. And so even though, I would say my understanding is that, the mass of work is definitely focused on like commercially important forest trees when it comes to kind of that assisted population migration element. There's definitely some, that other element of work on endangered plant and animal species for assisted, rescue assisted migration. But there's definitely a body of work going on sort of understory and herbaceous species. But yeah, I'm sure there's research out there I'm not aware of as far as some of those quote lower
Mm-hmm.
organisms.
Um, Dave said there's a group called Propagation Nation that is promoting planting 1 million coast redwoods and sequoia in Oregon and Washington every year. What science is behind such a massive effort, and what are your thoughts? And everyone, please feel free to turn your screens on if you'd like.
So yeah, that is a good question, and it's something I need to do more research on because there's a lot of interest and there's a lot going on around redwood sequoia movement. And I'm not sure I've quite made up my mind. Like I tend to be a little more on the conservative side, and think, oh, that's a long way to move species that are, I know there are folks, I mean, there are redwoods planted in Mercer Island and all over this area, and folks arguing that, look, these things have survived cold snaps and they're doing okay. There's not evidence yet that they're invasive. So I can see their argument, except that it feels a little bit like jumping the gun to me, and that there are less dramatic options available to us as far as bolstering our forest genetics and even near native species that are not quite so far afield or quite so evolutionarily removed from the ancestors that might have historically in the Eocene or whatever been up here. So I don't know. I'm skeptical a little bit, but I also know there are folks who have done a lot more work on that than I have. So I need to learn more on that.
Interesting comment from Andy. Andy said BC now requires matching seed sources to climate using the CBST tool, which is really fascinating that is like so deeply in trenched already in forest management.
Yeah, the Canadians are so far ahead. I don't necessarily mean that's not necessarily, depending on what your risk assessment is, that's good or bad. But because they rely so much on economics of forest production and also harder hit by climate impacts, they've had their hand forced, I think, in a way to be like, we've got to move these trees or lose them. And so I think that's what really made them take bold steps in matching up their modeling and their forest replanting regimes. So we're going to be learning a lot from them in the coming years.
Yeah, and I mean, is the seed lot selection tool is kind of the equivalent to the CBST here, right? That's
Yeah, and I
version of it.
didn't want to cram that into this presentation because I
Mhm.
obviously already crammed too much in. But that is a really neat tool to look at, even if you're just interested in sort of understanding what the potential climate impacts on our native species might be, or what it might look like to try and find climate adapted seeds for your land. It's a very cool tool to check out and play around with. It gives you an understanding of how climate can, is likely to be changing over time, and whose climate we're going to be receiving in the next 20 years or 30 years or whatever you want. So I encourage you to play around with it. Seed lot selection tool.
Yeah, I can drop a link in the chat in a moment. That's the end of the questions that I saw put into the chat. So if anybody wants to, just turn off their mutes and chat.
Yeah, it's been, it's quite a journey to dive into all of this, because there's such a huge amount of research going on right now. It's hard to keep up on. It's hard to, keep a grip on all the things people are thinking about and trying, which is both exciting and a little scary, because, I think there's a need for us to get on the same page as a society about some of these risks, that are substantial.
Tyler asked about our northernmost plants, like will we lose them altogether? And I think the same question maybe applies to our hottest, driest adapted plants that in regions that are going to get hotter and drier. Is there?
Yeah,
No, I guess they can move northward as well. So really just our northernmost plants.
Right, but you look at pinyon pine, not that, it's not necessarily going extinct, but, in those hot deserts, you look in some ways like areas that are losing forest essentially as ecosystem, because they're at the southern and hot edge and dry edge of where forests can survive. In the Southwest, where all that pinyon pine died off in 2002 and 2003, and similarly places where, in those sky islands and great, basin and range mountaintops, where there are these mountaintop communities with a lot of endemics that have nowhere to go, right? And very difficult to, once you get chased up to the top of the mountain, where can you go from there? And I think that some of the cases of folks being interested in assisted migration are those elements. It's like there's no easy way to move these, endemic pines except to the next mountain range north, which is sometimes across, international border, and then at the north edge, and it's especially concerning because in the far, in the poles, climate change is moving faster than anywhere else. So ecological disruption is greater there and hitting harder there. So it is really, that's scary.
Dave said Dave manages an 80-acre forest at 3,000 feet in the Cascades at Snoqualmie Pass. Should I be planting sources from Northern California for density? It's interesting, Dave.
Yeah. So, one thing that you might consider is that if you're at 3,000 feet, in some ways, moving things up elevation may carry fewer risks than moving things in latitude. Like things like the possible mismatch of photo period. So plants often, when they set bud and when they break bud, the things that kind of match a plant to the climate and to their place are sometimes at least controlled in part by photo period. So if you're moving things across latitudes, you're playing with fire a little bit there, that there may be some maladaptation. Whereas if you're moving things up in elevation, you might get away with some, less disruption. So if you have some room to take things from lower elevations, you actually might be safer doing that, or trying that again with this bet hedging. Maybe don't go all the way to Northern California. Maybe try some seeds from Southern Washington and Northern Oregon. Try some seeds from a little downslope. That would be, my inclination. And I think, again, the burden of sort of proof and care, the more dramatic thing you try, the more you better be willing to learn from it and helping all of us to learn from it and keeping an eye on it, right? If you want to be kind of safe and, just hedging your bets, I think trying some of the more conservative approaches may be more effective in the long run, certainly less risky. That's my thought anyway.
Erica asked about assisted migration happening in like high density logging production forests? Is there that sort of mitigation happening too? And I was thinking about this earlier when you said that on the checklist of considerations for whether a plant might or a tree might be prone to invasion. It was, does it grow fast? Which for a production forest you would want.
Mhm.
So
Um, so is this just talking about sort of forestry, industry forests or working forests? Is that sort of the question, as opposed to like wilderness? Or are we talking about like plantations? Which I guess there's a fine line there. I mean, obviously, people plant all sorts of things. Like one of the complaints, sorry, no, I'm going off, but one of the complaints about some of the, plant a million tree initiatives in various countries is that people are planting trees that are not ecologically matched, planting hundreds of acres of teak forests where they don't belong, and or at least are not very supportive of biodiversity. I mean, my hope would be that, the logging forestry industry is planting the right plants in the right place and maybe not being too bold with the kinds of substitutions they're making, more following the kinds, like in BC, which is, in a way, kind of a bold move to require the movement along climate projections. That's actually pretty careful, right? They have good models based on reciprocal transplants and multiple climate models showing where, native species might be best put, and they're putting them there. That seems, on the whole, wiser than making really radical moves like plantations of redwood, or I'm not sure what the suggestion is, but unless you're really hoping to learn something dramatic and pass that on and keep an eye on those as experimental plantings, keeping the risks low seems right.
Don asked, should we move whole plant communities or species individualistically? Or is there discussion around that, I guess?
I mean, I think, in some ways it's like a daunting, asking that question sort of is what is a challenge to the idea of assisted migration, because to some extent, like, we can't necessarily move everything. We can't move the whole Appalachian forest up into New England. We don't have the knowledge and the capability for most, to propagate the plants. But I think it's a good question because it makes you think, despite the fact that plants move individualistically and adapt, they also do have interrelations, and they have interrelations with fungal communities in the soil. And there are studies showing that those mismatches can have negative impacts. So I guess all I can say is that we have a lot to learn about which of those interactions between plants or between plants and fungi are really critical and which ones aren't as critical. But I feel like, as far as I know, we're not anywhere near there yet. I think we can learn by looking at ecosystems and say, well, if I need my ecosystem to have more climate adapted plants, here are some that live together peacefully in other places. And I think there's some, we can learn from existing natural systems that way and mimic them.
Maybe we have time for one more question. If anybody wants to throw one out there. Not, I have a question.
I'm happy to answer that. I was just looking at Andy Bauer's comment there.
Yeah, sorry. If I missed any questions, please let me know. Or if anybody wanted to discuss some of the points they threw in here that were not phrased as questions necessarily.
He says the general rule that local is best still holds true. The difference is that assisted migration focuses on climatically local rather than geographically local. That's, right. I think what we understand as being local maybe is what's changing.
So one question I have is kind of for the group here. I know that there's several forest owners and maybe some forest managers on the chat still. quick show of hands, is anybody like thinking about doing this in their own forests? Or already doing? Any Richard, Pitt, anybody else? Richard, what are you doing?
We're
Dave?
certainly not very dramatic. We've just ordered seedlings from one seed zone south,
Mhm.
rejected any attempts to substitute from one seed zone to even one seed zone from the north. So
Mhm.
we're not dramatic, but that's our effort.
Anybody else? Dave, I know you said you're thinking about it. Kit, have you done it or are you thinking about it?
No, at Snoqualmie Pass, we're just thinking about it, trying to think ahead to a population where we have mostly silver fir and hemlock, and we're nervous about what things might look like 100 years from now.
Yeah. It's a great
Anybody
thing.
else? Might not be anybody else doing it. It's a question that our forestry team gets a lot, and I know Kirk, our director of forestry, his response to should I be doing it is usually like, do it a little, don't put all your money on this, don't plant a whole stand of whatever it is. But you could try it out. Or do. I mean, some people are more risk prone, I guess. And he's usually talking about more southerly seed sources and not, I don't think anyone has actually approached us about, non-native species that are not native to this region. But potentially that's something people are thinking about too. Well, we're a couple minutes over and I want to respect everyone's time. So thank you so much, Matt, for this great presentation. It is a fascinating topic. And Andy, yeah, small risks over large areas, large risks over small areas. That's very wise. I like that. That could be the title of this fireside chat if we do it again or a paper. Um, if like I said, if you're in the area and you want to hear more about this and see some of the assisted migration plans at Oxbow, we're doing a tour there with Matt and with several other folks from the Mountains of Sound Greenway Trust and NNRG on October 6th, which is a Friday. And it's between Duval and Carnation. So if you're in the area, I will email out a link to that event along with some of the other resources we mentioned here in a follow-up email so you can sign up if you'd like. Thanks so much, everyone, for your questions. And next month, our Fireside Chat will likely be on third Wednesday. So that's October 18th, same time. And I think the topic next month, I think our October topic is kind of forest foraging, which is like a fun one we do every year. Slightly more lighthearted, maybe. Not that this was dark, but it's less scientific, I would say. So, yeah, hope you can all make it. Matt, thank you so much.
Yeah,
It was
nice to
great
meet you
having
all.
you.